Alright students, today we're going to talk about inscribed angles. So we've already seen inscribed triangles. So now we're going to, and I talked about inscribed angles the first day. So now we're going to talk about a couple different types of inscribed angles. So the first thing that we're going to want to do is create a circle with a radius of 6 centimeters. Alright, so here we go. I'm going to put my bullseye on my point A and draw a circle that, whoa, that didn't work out well. Let's try again. Circle with a radius of 6 centimeters. Okay. And then I'm going to just draw a little dash mark here because I want to remember that my radius is 6 centimeters. Alright, so next it says create a point in quadrant 3 and label it D. Okay, so quadrant 3 is going to be down here somewhere, so I'm going to label this guy D. Then create a point in quadrant 4 of the circle and label it E, so quadrant 4 is over here. Next, create segments. What must the point? Oh, in quadrant 1 I gotta have C. Sorry about that. Quadrant 1 I got C. So then create segments CD. So CD and DE. Okay. In green and AC. So AC and AE. Alright, so I've got two sets of angles here. This first one, as we know, the angle CAE is a central angle. So if I get my protractor and I measure this guy, let's see what this guy is. So it is roughly, let's say 94 degrees. So this guy is 94 degrees. So angle CAE is 94 degrees. So that's my central angle. Now the angle that was formed by these same 2 points, C and E, but now it goes to the other side of the circle. It doesn't stop in the center, it goes on the outside. So all 3 points of this angle is on the circumcenter of this triangle. Well, let's see. I'm sorry, the circumcenter of this circle, not a triangle. What am I thinking here? So I'm going to measure this guy, and this guy is roughly 45, 46, 47. So this guy is 47 degrees. So if you take a look at this, the first thing that you probably should notice is that 47 is half of 94. So this inscribed angle CDE is half of its central angle CAE. That's very important. That's one of the big things that you got to make sure that you memorize. Your central angle, my inscribed angle, is half. Now it doesn't matter where I move this on the circumference of the circle. It's still going to be half of this angle here. Alright, so now let's see what we're doing here. Now we're going to build another one. So this one's just an inscribed angle where my 3 points are on the circumference of a circle. And its relationship is half of the central angle. So this guy is half the central angle. Alright, so now we're going to draw a new one. So now we're going to do an inscribed angle where I'm using a diameter. So I'm going to create a diameter in red. So here we go. And I'm going to label the points C and E. And that's not right. It should be F, kiddos. It should be F and G. So F and G here. Okay, next create the segments FC. So we're going to go from F to C here. And from C to G. Right here. Okay, so now I'm using the diameter of my circle as a leg of this triangle that I got going on here, which is really an inscribed angle because my inscribed angle is FCG. That's my inscribed angle here. If I take a look at this, let's measure these guys. So if I measure angle F here, I'm sitting at 25. If I go over here and measure angle C, oh, look at that. This guy is 90 degrees. This is a right angle. And then if I come over here and measure angle G, this guy is 65 degrees. Which should make sense. If this guy's 90 degrees, and these two added together have to equal 90 as well. So, if I'm using, let's look at these angles now. So, measurement of GFC is 25 degrees. Measurement of FCG is 90 degrees. And measurement of CGF is 65 degrees. So, this guy is a right triangle. When I'm using the hypotenuse, this is my diameter. Hypotenuse of my circle is, or the hypotenuse of my triangle is the circle's diameter. But my inscribed angle can be any way you want to look at that. I can look at F, so here's my inscribed angle here. I can look at C, here's my inscribed angle. Or I can look at G, this is my inscribed angle here. Any one of those three can be an inscribed angle. Alright, next one is the same arc. So what we're going to do is we're going to create 2 points H and J. Creating H and J on the circle between, this should be F and C. We're going to put these guys up here. So this is F. Oops, this is H, sorry. H. And then I'm going to put this guy here is J. Okay, so I got points H and J. Now I'm going to create the segments DH. So right here. DH, DJ. DJ, HE, and JE. Okay. So now I have 2 inscribed angles. I have DHE and I have DJE. Here. So let's use our protractor and let's measure these guys. Let's see what this is. And I have the inscribed angles HDJ and HEJ. So if you notice, these guys have the same arc. If you look right here, this angle HDJ has this arc, and angle HEJ shares the same arc. So that means these 2 inscribed angles have to be the same. So let's take a look at this guy. So if I measure this, this guy is 11 So this guy is 11 degrees. So HDJ is 11 degrees. Let's take a look at this guy. Lo and behold, this guy is also 11 degrees. Which should make sense because we're using the same arc. So if I'm looking at DHE, if I'm going the opposite way from up here, and DJE, aren't they sharing the same arc down here as well? So these angles should also be congruent. So let's take a look at this. We've got this guy is 47. And then let's look at angle J here. And 47. So both of these guys are the same. So what that's telling you here is if I have an inscribed angle and they have the same arc, then the angles have to be the same no matter which way you're looking at this. If I have an inscribed angle that includes, if I draw a triangle, it includes the diameter, then the inscribed angle will form a 90 degrees up here. It doesn't matter where you move this guy. And then finally, if I have a central angle and an inscribed angle, the inscribed angle is half of the central angle. So those are the key takeaways for this.